We're live.
Oh.
Welcome.
There we go. Hello, media.
Welcome to the Thinking About Computers podcast, where we talk about thinking about computers. Our guest today, Ale Escontrela, famous Ale. Ale is a PhD student here at Berkeley, same year as me and Lisa. Ale studies robots. Grew up in Miami.
Advised by the famous Peter Beal, correct?
Yeah. Very fun dude. Excited to hear about your take on the world of research.
Yeah, I'm happy to be here. Joined by two lovely people.
Mm-hmm.
Are you a fan of the pod?
I listened to Amisha's episode.
All right.
Just to see if I could find any stills that I could screenshot. Him looking goofy and then send to him and kind of ridiculed him.
Yeah. Did
Um,
he find anything?
no, he's just so photogenic.
I know, it's terrible.
Batman. Gets up early, goes to bed early.
Yeah. Gets up so early. It's like hanging out with him. It's like 8 p.m. rolls around. Time for bed.
Yeah. I always feel bad. It's like, it's like, I'm not worth hanging out with past 8 p.m.
Mm-hmm.
Yeah.
Nobody is Nobody is.
Well, hopefully one day he'll find someone who's worth staying up past 8 p.m.
Yeah.
We're all rooting for him.
Yeah.
That's love.
I wouldn't count on it though.
How's your routine?
Like daily routine?
Yeah.
I reworked my daily routine substantially because when I was starting the PhD, I was waking up like at 9 a.m., 9:30, getting to the office at like 10:30.
Yeah.
And then leaving at like 7 p.m., 7:30 p.m. And once you have like a partner, that doesn't really fly anymore.
Yep.
And it's also just it's a young man's game to wake up late, We're getting old. You gotta settle into old people routines. So now I wake up like at 7 a.m. and I go on a run, eat the same breakfast every morning, and then get started at like 9 a.m. at work.
What time do you leave the office usually?
Still like 6:30, but like an hour or so earlier than usual. Adelaine's nice because by the time my partner gets home from San Francisco, we're home at the same time.
Yeah, she's got the longer commute, right?
Roughly, yeah, like a little bit longer.
She gets up earlier, right? I feel like when I get to the gym, she's like at least halfway done with her workout.
Yeah, Wanta's at the gym at like 6:30 a.m. It makes me feel bad every morning. There's like this book called The Ride of a Lifetime by Bob Iger, the CEO again of Disney, I guess.
Mm-hmm.
And he's like, I wake up at 4 a.m. just so that I know that I'm up before anybody else and I'm already beating them.
Yeah.
It's so like psychotic.
I don't know though. I didn't have that in high school. I definitely had that in high school. Like we'd have morning practice before school, and so morning practice was 5:30 to 7:15.
Mm-hmm.
And so you do your morning practice. You eat breakfast. I would go hang out in my math teacher's class. She'd let us hang out in the morning. My school started at 9, so finish practice at 7:15, maybe get breakfast. You get to school by 8:15. You do homework or something from 8:15 to 9. School starts, everyone's rolling in half awake, and I'm my day started so long ago.
Yeah.
I do feel superior.
It's been years for me.
Yeah, exactly. You don't understand what I've been through.
9 a.m. is a nice start. That's reasonable.
Yeah.
I feel like my school and a lot of schools are 8 a.m. starts.
Yeah.
7:30 a.m. starts. It's insane.
Yeah, it's ridiculous. I think my school system got it right in that I don't know, for elementary school, they had the typical school started at 7:30 or something, which I think is reasonable because parents need to get to work at 9.
Mm-hmm.
For middle school, I think it started at 8 or 8:15. They might have changed it so that middle school starts at 9. But for high school, it's the parents don't drop their kids off at high school typically. It's your kids would drive and they take the bus. So I think they started at 8:45 for a while. And then halfway through, they're like, everyone's coming in at 9. Let's just start school at 9. But yeah, so I think it was 9 to 4 or something. It's good. It's a good schedule. I'd recommend it.
That can be good for the brain to have kids wake up at like 6 a.m. to go to school at 7:30.
Yeah, I just don't know what you would do at 7:30.
Live in Europe, and that way your kids can actually take the bus to school. The public bus.
Yeah. Okay, so I know we were supposed to talk about research first and then not research, but we're already here. So you grew up where?
So I was born in Venezuela to Spanish parents. And then when I was 4, I moved to Miami, Florida.
Was this an eventful move?
Kind of, yeah. So my mom, it was pretty eventful. My mom basically kidnapped me. Oh, did I ever told you this? You sound like you already, yeah. I don't think I've told you this, right? Yeah, my mom basically kidnapped me because Venezuela was not so stable at the time. You know, Hugo Chavez and corruption and not pleasant stuff. But my dad had like a good gig. He was comfortable. He's like, all right, I'm gonna stay here and we'll just weather the storm. And my mom was like, okay, sounds good. Let's go to Disney with the kids. Maybe you can stay back and work. And so while we're in Disneyland or something, so we're in Disneyland at the hotel, she calls my dad and is like, okay, we're not going to go back. I'm not fucking leaving.
Yeah, I mean, Disney. Disney, the perfect place.
Yeah.
Can't leave.
And so, yeah, my dad had to like pick up his life and go to Miami, Florida.
And this is exactly what Bob Iger was waking up at 4 a.m. for, right? So that
Right.
people get to Disney and they're like, oh my God, this is it.
Bob Iger is the reason I'm here. Thank you, Bob Iger. Yeah, so raised in Miami until about college age. Then I went to Orlando for a few years to state school, and then I transferred over to Georgia Tech in Atlanta for undergrad.
Transferring, not very common, typically, or
I don't know. I just felt like, the transfer was motivated because I wanted to do aerospace engineering. And I did do aerospace engineering for my undergrad. And the school I was at, UCF, had a good program. It was okay. But Georgia Tech had like a really good program, and it just made sense at the time.
So why didn't you just go to Georgia Tech from the beginning?
Yeah, well, different from all my colleagues in Bear, I was really bad at high school.
Got
it. I did not take academics seriously until like a year into college.
Okay.
And then thought maybe it was time to, to learn something. And,
What flipped the switch?
I don't know. I just thought at some point it just became cool to me. I felt like, I don't know, my high school makes everything so not cool. I don't know. I feel like public education makes everything not cool in a way, depending on your school, and your upbringing and stuff. But for me, it just felt like it didn't take anything. Like I wasn't that interested in anything in high school. Like maybe U.S. history, maybe the arts, but like science and stuff was okay. I mean, I did well at it, but I wasn't like super interested.
Yeah.
Not motivated enough to like compete with people applying to like the good schools.
Yeah.
And then in college, it kind of clicked for me. I had a good physics professor, a very stern, mean, but really interesting physics professor, and he kind of got the ball rolling on my interest in like STEM, basically.
I had a similar experience, but in 8th grade, where like I was really not interested in school, and like one science teacher really like flipped the switch for me and like got me interested in it. Shout out to her.
That's pretty cool. 8th grade is a nice point to become interested.
Yes, that was the convenient timing.
The first year of college is like the last stop.
Yes,
Yeah.
it's
Like
much
anything
tougher.
after that, it's a little bit.
Yeah.
Yeah.
But hey, now we're here.
Yeah. So how does one transfer colleges? How do you? I don't know how the process works.
It's really just like the undergrad process.
Okay.
Except I didn't have to retake my SAT or ACT.
Mm-hmm.
You can if you want to, but I have done well enough on those for like my undergrad.
Yeah.
Or for my in senior year of high school, I did well enough on those. I only had to show that I had taken, I think, like the classes required for my associate's degree,
Mm-hmm.
maybe, and then a few STEM classes. I think it's been a while,
Mm-hmm.
and you just apply, just like if it were applying for undergrad or high school.
Interesting.
Normally, they're not as likely to accept transfer applicants because it doesn't make sense most of the time. It's kind of like, why not just stay where you're at?
Right.
Yeah, so I got lucky.
Dang, crazy. I'm pretty sure I got waitlisted at Georgia Tech, or just got flat out rejected. Don't remember.
Really?
Yeah.
That's
Yeah.
for the better.
Yeah. All right. Damn. How was Georgia Tech?
I mean, the aerospace program was great, but I guess you were applying for CS.
Yeah, I think so.
Yeah, that's a meat grinder.
Really?
Yeah, it's like a depression pit. It is not good.
Depression bill.
Yeah, it is. I don't know. It wouldn't.
Mm-hmm.
I mean, Tech's a great school, don't get me wrong, but
Mm-hmm.
I think the vibes could be better.
Yeah.
In the CS department.
I feel like it's like that for most schools. I feel like Berkeley CS5, undergrad CS vibes could be better.
Mm-hmm.
Yeah.
I don't know anyone who was like CS vibes were fantastic.
Yeah, for undergrad, I can't think of.
Yeah, like a small liberal arts school
Yeah.
where the class sizes are small. I mean, it's all these problems with like research. Like Berkeley has this too, right?
Right. Yeah.
There's just
It's too many.
20,000 CS students and then like, I don't know, 10 TAs
Yeah, exactly.
total in the whole program.
Yeah.
Across 20 classes.
Yeah. So did you want to be a rocket scientist?
For a while I did.
And why aren't you one?
So I wanted to work at Skunk Works. I don't know if you know about Lockheed Martin's Skunk Works.
I know Lockheed Martin, but not skunk. Like the
Yeah.
animal.
Skunk Works is like the Google brain of Lockheed Martin. That's a fair comparison.
Okay.
It's like this super tight, small team of like crackpot scientists and amazing
Think tank.
aerospace engineers, and they make all the experimental aircrafts for like NASA, for the Army. Like I think they made the B-52 stealth bomber. I don't know if you've seen that, or they made like they're making like the new supersonic commercial aircraft for NASA, like the prototypes. So they're the only people really innovating in aerospace engineering. It felt at the time, and the reason I say this is because a lot of the jobs that you would get out of Georgia Tech are like at Boeing or at Airbus or even at Lockheed Martin, like just military, industrial. And those jobs end up being just like a lot of small like performance optimizations, like let's increase the, let's remove the rivets from the plane and that way we get like 2% more efficiency. And not only that, but it's like, you're doing like complicated stuff like fluid dynamics, simulating crazy airfoils. You get paid like $70K a year.
Got it.
And I could go work at Google.
Yeah.
I get paid like $200,000 a year to redesign the buttons on Google Calendar. It just like financially it made more sense, and also CS just felt more fertile in terms of the amount of research you could do or the amount of things you could develop. It just feels way more fertile.
Mm-hmm.
I mean, it's a newer kind of field, but yeah, it didn't make sense really to like stay in aerospace for me, given my interests.
And so you moved to, did you go straight to Google or?
So I first worked with this guy called Frank Dellert.
Okay.
He does structure from motion work, like in computer vision. You know this.
Yeah.
I don't know.
Yeah, so structure from motion. I mean, his work is super cool. Like, do you know the Skydio drones?
No.
It's like the drones that like can follow you around and can map buildings and stuff. The idea is like you have a bunch of camera images. You have no other information other than the pixels, usually. Maybe some like IMU sensors or some sort of like odometry sensors that tells you velocity.
Mhm.
And from this information, try to like reconstruct the world.
Okay.
So there's a lot of like works, like some seminal works are like building Rome in a day. I think that paper's called, where it's like they got all the images of Rome from Flickr.
Oh.
And then they built like a 3D map of Rome just from the images. Super cool stuff. So I did work in that field for a while. Specifically these things called like factor graphs, which are these like bipartite graph structures that you can use to model like complex optimization problems, including structure for motion or like state estimation for robotics. And then we got into reinforcement learning, kind of. We got into like optimal control / model predictive control, trajectory optimization. And then I realized that like if you want to do optimization for extremely hard problems, like very nonlinear dynamics, uncertain estimation of the world, so you don't know like how slippery or how rough the ground is, or whether that actually is there. I realized that you can't just do like PR. You can't just formulate everything into like optimization problems where you like build a model and then optimize it. And so that got us into like reinforcement learning, and just using like simulators and a ton of compute instead of actually thinking about how to structure a problem.
Yeah. Way easier, right? The computers do the work for you.
Yeah, way easier for me. I can just kind of like drop a little robot in the simulator and have it like vibrate until stuff works. But yeah, and then I got to work with some of the cool people at Google Brain Robotics, doing legged locomotion, so like legged robots. We built our own robot, and we actually made like a thing that we call Barcore. If you know the American Kennel Club competitions, like those competitions where it's like the dog is like running around and has to like do the weave poles or has to go up the A-frame, and the whole time the person's like giving it treats. We built a course for a robot dog, and we like got it to do the whole thing in a pretty fast time. I don't remember if it beat a real dog, but
wait, that's incredibly impressive, because I see these robot dogs, and I swear to God, they like trip over their own foot all the time.
Yeah. This one still tripped.
Okay. Well, so like, how does this work? I keep hearing about these robotic, like, it's able to do things that I would think are impressive, but then I see the like, I don't know, demos of like robot dogs. And like I remember I saw one of like robot dogs like, tracking an object and then like chasing it. And like, I don't know, it's just it's all wonky, kind of like jitters a little bit. Yeah. Sometimes it'll just like keep running or do something, and then you see the like person controlling it having to run over and get it. Like, why don't I see robots doing really cool stuff? Are you just hiding it?
Yeah, we're just hiding it. Okay. We have all the secrets. I mean, it's closed at this point. Like, we're not.
I got it.
The robotics field has decided that we're just going to make one big startup, and it's, no. I mean, so yeah, that's like that's kind of at the heart of the problem. Where I guess the cool stuff involves interacting with the world. Like the walking part's okay, right? It's minimal interaction with the world, and there's a lot of room for failure. Like, walking is a relatively easy problem, especially when you're like a legged robot, because you're kind of passively stable. So you have 4 feet on the ground, and you can just stand still and you won't fall.
Right.
Maybe there's a little bit of touching and feeling to see like if you should go there or not, but there's nowhere near the level of precision required to, let's say, like pick up these keys, or like turn the dial on that microphone, open the can. And I think that's what the field is now gravitating to. A lot of people consider like locomotion mainly solved I think minus a few like cases like agility, for instance, like very fast running robots is still a case where there could be better algorithms, but for the most part, like the problem of walking upstairs or walking in this building is mostly solved. And now we're moving towards like manipulation in the wild, out of the factory setting, and those are way harder problems that there are solutions to, but they're still not very great.
I see.
So you think robots will replace dogs in our lifetime?
Robots will replace. I mean, I already have a robot dog at home. I thought the real dog was making a mess.
Yeah.
I mean, what are the Sony Ibos? That's what I have at home. The Sony robot dogs. I don't know if you remember those.
No.
From the 90s.
The eye dogs?
Eye dogs? Yeah, I remember those.
Yeah, the ones that had the ears that would go up.
Exactly.
It would move. It would light up. You could play music.
You remember that?
Wow.
She got you one.
I was a Nintendogs guy. Software over hardware. So, yeah.
Is that a game?
It was a Nintendo DS game. It was like
Yeah,
the very first
oh,
Nintendo
That
DS game.
sounds familiar.
Yeah.
Yeah. Wow. Nintendo DS.
I also had a real dog. It was pretty good.
Those are pretty cool too, I think. Yeah.
So, with this like fine grained control stuff, it's hard for me to understand how much of this is a software problem and how much of this is a hardware problem. Of like, how much of it is a computer vision problem, and how much of it is like I need to figure out like how much pressure to put to turn this dial without breaking it or something.
I mean, if I were to like assign costs to it, if you had a massive budget, there is no hardware problem. I mean, I don't know if you've seen the Tesla humanoid. Like that hardware is already very capable of like even picking up small things using my fingernails or handling like large objects. But the hard part is learning behaviors. So learning skills that are actually meaningful. And that is still very unsolved. The only approach that like is yielding results right now scales terribly, and it's just behavior cloning. You know, let's just get a bunch of humans to like guide it around, and then we'll just behavior clone that and see how well it works. But that has like terrible scaling properties, right? I mean, there's companies that are sending engineers to like Airbnbs to gather data at like different kitchens, and that just has terrible scaling properties. So, you know, what I am interested in is using reinforcement learning, or more so like interactive learning. So the idea of not only like getting demos, but also exploring, letting the agent explore for itself and get some reward, get some feedback, learn from that feedback, and then kind of try new things. And I think that's more scalable because at the limit where you can just kind of trust it enough to let it run loose in the world, then it can start learning from its own experiences, and you don't have to like give it exactly the motor, you know, torques that it needs to perform a task. You can kind of learn them on its own. So I think that's like the missing piece of the puzzle, is how to scale, how to make those algorithms perform really well and have them, you know, be general enough so they can solve hard problems. Still a lot of work to do there. Yeah.
So, for some reason, I don't like RL, and I don't really know why. Because I don't do RL. I've never really done RL. Can you explain to me why RL seems to be somewhat of a polarizing topic?
Yeah.
Or do you think it is? Maybe it's not.
I mean, I don't think it's that polarizing. I just think that people either expect too much of it or they don't understand it.
Okay.
So there's like this common misconception that, you know, RL is just doing like supervised learning on the test data, or you're evaluating on the test data, you know, and training on it too. Or there's this misconception that it just like doesn't work outright. Like people will just say like, I tried, it doesn't work.
Yeah.
The problem is that it's a really hard problem. So you don't have labels, right? You don't have labels at all. You have to make your own kind of algorithm now that can learn without labels. And it's not like unsupervised learning where there is some structure that's like good and you just want to learn it. It's like, no. What you start with is garbage. It's just this thing that flops around.
Mhm.
And you now need to make it move around. Or you need to make decisions that like you prefer or that you like. You like to see that. That's a really hard problem. I think it's like one of the hardest problems to solve, especially when we talk about humanoid robotics with like visual inputs and long-term decision making. Many problems like to solve there. The other side of the coin is that I think a lot of the papers in the field are unnecessarily complex and theoretical, where they don't need to be. I don't think it's like the most accessible field. I mean, if you look at the most cited papers of RL in the past 10 years, they're the ones that are easier to read and have like good open source implementations. Not necessarily the best performing ones. Because oftentimes the best performing ones are just written like these, like a textbook that's like full of proofs and, you know, who cares? Like, just give me the details that matter and give me a good implementation, and that's what we needed.
That's most fields of academic computer science. Like, the papers are really heavy, really kind of not built to be teaching you what's going on, but built to look hard. Which kind of makes sense because like it's often written for reviewers who you need to convince that it's very novel and very hard, because that's what it takes to get into a conference.
Right.
And then like in distributed systems, like a lot of the most cited papers are like, we just took this complicated paper and we made it simpler, and here's how you can understand it better.
Yeah, like boiling down the details that matter. That's the main contribution, right? Like, I'll cite that paper, not the more complex one. So we can get into why RL is hard. I mean, but we can also get into like how it's good. Like, there's really good algorithms now that perform very well. And I don't just mean like, have you heard of PPO? The one that everybody uses. It's famous in Berkeley because like John Schulman made it. And,
is he the one?
Yeah, he's the one. Okay. And then he went on to do ChatGPT, which uses PPO. So
famously, we were also on a flight with him once, right?
Yeah. He was all messed up for the paparazzi. But there's really strong algorithms now, and there's been such incredible advancements in reinforcement learning in the past 5 years. I sometimes see like people think like, oh, nothing's really happened in RL for the past 5 years. A lot has happened. It either just hasn't been open sourced, or it's been overshadowed by like the LLM hype frenzy. But it is a very exciting and fast moving field. I think there's like a lot to do there.
I mean, it seems like it's still, I guess, as someone in AI, like the RL field seems pretty big, but maybe it's also just like a large presence at Berkeley or something.
I think Berkeley's like particularly strong because they have Sergey and Peter's lab. And now just getting into RL kind of. So Stanford's also in the area. And, like, Chelsea Finn's working on RL there. Stefano worked on RL. So I think the Bay Area is like probably the hub for reinforcement learning.
So do you want to explain PPO to me?
PPO.
How hard is it to explain?
It's not that hard. So, and it boils down to one of the main problems in reinforcement learning, which is how much to trust your data.
Okay.
Because the problem with reinforcement learning is that, you know, you have this big data set that you're actually gathering over time, right? Like initially your data set size is 0 because you haven't gotten any experience in the world. And then, you know, I take a couple actions, maybe I take a few thousand actions, and I observe the outcome. What rewards did I get? Did I do well? Did I succeed? And then you store those in the data set. Now, it'd be nice if like all that experience was with respect to like my current self, right? Like I took these actions and they performed this well. And so now I can immediately see like which sequences of actions are best and which are worse. What happens is that in practice, it's this like, you have multiple behaviors from arbitrary versions of your past self in the data set, because there's this process of I gather experience, I update myself, I learn from it, and I gather new experience with my updated self, I learn from it. And so data quickly becomes what's called stale.
Right.
Meaning either it's like bad, it's just like not good data, or it's like not clear how to map this experience onto your current incarnation. So PPO approaches this by using trust regions, which is to say like, okay, my current self would like assign this much probability to this action, but my past self assigned like almost no probability to that action. Probably shouldn't really trust it that much since it's like pretty out of distribution, or it's pretty stale at this point.
Right.
So the idea is like you leverage trust regions, like make sure that you're only updating enough to the point where you like are confident you're making a good update in parameter space, but you don't update too much where you have like destructive updates that take you to like, OOD states or actions. Yeah, that's like PPO. I mean, there's so much more to the world than PPO. The cooler algorithms now are like world model stuff. Like all the cool kids are doing world models.
I keep hearing about this world model.
Yeah.
Peter's group just had a world model thing, right? Or is that all he does? I have no idea.
Peter's group had the language world model.
Oh yeah, is that different?
That doesn't have decision making, but that was cool. As far as I understand, it was like speech, text, and video. It was like a multimodal transformer trained on all three.
Yeah,
like,
I think it was something like that.
I think it was like 1 million context ring attention was the main thing that was like impressive.
Yeah, the main thing I remember was the context.
The context length.
And then, whatever X number of days later, Gemini 1.5, 1 million context length.
Yeah.
But
yeah, kind of got
cool either way.
Yeah, the context length stuff is interesting. But yeah, in the context of reinforcement learning, the idea is like you learn a simulator. So like it's expensive to gather data, right? In the real world, like my robot moves slow. But what you can do instead is that you can train a simulator. You can actually learn a simulator from your past experience. So like it's pretty like the idea is pretty simple, right? Like I have my current state. Hypothetically, let's say I take this action, predict what's going to happen next.
Got it.
And predict what's going to keep on happening if I unroll this sequence of actions. What that lets you do is have massive like parallel batches of data within this learned simulator at no added cost in terms of real world data.
Right.
And normally it's like really good performance. So we had a paper where like we used this approach and we had a dog learn to walk in the real world, like from its back like a cockroach in 30 minutes. Like starting from scratch, and no simulator. We had it using this kind of approach. It could learn to like pick and place in the real world in like 8 hours, and it was cool because for that experiment, like we started at around 2 p.m. and it learned, then sunset started coming in and the level of light decreased,
right?
And it just went on the fritz. Like performed poorly. It was like, hold on, everything's darker now. I don't know,
right?
But then it learned again in the dark, and the next time daytime rolled around, it was okay. Like it had seen daylight already, so it kind of remembered its experience. Same for the evening experiments.
It's very like sci-fi-y, like robots and AI and stuff. Does that aspect of it like excite you at all about working in robotics?
It excites me quite a bit, but I feel like the just focusing on robotics for the sake of getting robotics results can just lead to like very short-term gains. I think robotics has such high overhead. Like for one PhD student to develop cool RL algorithms and kind of like state-of-the-art robotics results, it's a lot. It honestly takes like a team of engineers to get good robotics experiments. So I think to get good results in like RL, it's probably better, or like to improve RL algorithms, it's probably better to focus in sim. Have like, a big benchmark of environments you care about. So right now I work with like a benchmark of like 30 environments that different games like Atari, for instance, or different kinds of games, simulators that have some reward mechanism. And I'll just test on all of these to get some signal. I think for development purposes, it's probably better. But honestly, like you asked if it excites me, it does, but it's also so much work to get a robot. Like it's so much pain to get a robotics result. It's all engineering. It's no research.
Damn.
Yeah.
What's the engineering part?
Just fixing like Ethernet socket issues, or like, you know, the motor burns out and I have to replace the stator.
Mm-hmm.
You know, the battery's on the fritz, so you have to get a replacement, and that takes a week. It's like just a lot of like manual labor.
Yeah.
And these things were like, the lightest ones were like 40 pounds, so there's a lot of carrying these heavy loads.
So why not just pivot to like pure RL, like just solve Pong or whatever
That's
it's
what I
hard
did.
games, like that
That's
sort
what
of thing. I don't know how many of those strictly digital games are left to solve. They solved poker and diplomacy and all that stuff, but no robots needed.
Yeah, no robots needed. I mean, the Atari games have all been pretty much like solved to oblivion by DeepMind, to the point where it's like just they're having a field day with it. They just put out a paper called Meme like a year ago.
Solved.
And it's like
memes or
well, it's just like they learn. It's like a single policy that solves all the Atari games, or solves them to like human level performance in less time than a human, or with less experience than a human. So Atari solved, but there's more challenging environments that like can be produced in sim. There's pretty good simulators. Nintendo, yeah, all the video games.
Yeah.
You know, all the AAA games. You gotta beat like Fortnite. But there's a lot of interesting stuff to do in sim still. That's a good test bed.
How much of RL research is pure sim?
Depends on the conference. Yeah.
So in a non-sim result, like I'm just trying to picture, maybe I should read more RL papers, but is it like, we got a dog to learn to walk in 4 hours? Like that's your experiment? Like what?
So for a robotics conference, that result is like, makes a lot of sense to frame it that way.
Yeah.
Because especially when you look at like other methods, either they couldn't do it or they did it much, much more slowly. But for a conference like NeurIPS, they wouldn't really care too much about it because they want to see more like aggregate performance. Like show me that it works better than all these algorithms, you know, across all tasks. And so for NeurIPS, you got to burn more trees, I guess. You got to like run more experiments for longer, run more seeds. You know, maybe even have proofs that like show convergence properties.
What are your thoughts on proofs and papers, RL papers?
I don't care for them at all.
Yeah. It's been a while since I've seen a proof in a paper that has really added to the paper. Like,
yeah, it's tough.
Yeah, I read this one paper the other day. It was in a reading group, and like, it was a cool paper, but it was one of those things where they just definition after definition. I think they may have had some like proofs and lemmas in there, and I don't know what they were for, but the actual method, we were like, okay, but like, what are they doing? Like, they have the results, and like, I get their theoretical setup of like what a concept is. And then we found the description of their method in the appendix.
Wow, they got it backwards.
Yeah,
Systems conferences,
like,
it's like
That's brutal.
no proofs at all in the paper.
Yeah.
20-page appendix of proofs.
Right.
Like if you have proofs. I mean, like, but like you don't start the paper with them.
Yeah. It
This
was
paper got accepted.
Yeah, I think it got accepted in NeurIPS.
Into NeurIPS?
Yeah.
Yes.
It wasn't like a bad paper. It just suffered from this like, I don't know, I call it like people wanting to sound smart.
Yeah.
Of like, oh, this is such an academic endeavor.
Yeah.
Like we're really rethinking of the problem in terms of abstract algebra. And like, that's cool and that's fun to think about. And I think that's fine to put in your paper as like a fun thought, but like, at the end of the day, the results that you're showing, I need to know how you get them.
Yeah.
And I don't know how you get them based on like describing how diffusion models fit into abstract algebra. Like,
I think it's really a question of audience. Like there are audiences that are interested in like different models of like mathematically modeling problems, like thinking about them.
Yeah.
And, like, it's a very different audience than like the audience that wants to build out systems and experiment on them or wants to, do whatever reinforcement learning stuff.
Right. Yeah, and within every field, there's like two camps as well, right?
Yeah.
There's the theoretical side, and like the funniest thing, RL, is like just how different those camps are. Because like the theoretical camp would be like, okay, we proved convergence of this algorithm on these environments, and then you see the environments, and it's like a grid world,
right?
Like a 2D like little point moving around.
Yeah.
And the other camp's like, shoot, I figured that I just randomly shift the input image by 4 pixels.
Yeah.
And that algorithm has like, humanoids learning to stand up and run and like, robots learning to cook.
Yeah.
I don't know theories. It's just like,
just
the
all
camps are
vibes.
so different. All vibes. It's like, just shift it. Maybe there's a little less overfitting going on. I don't know.
Yeah, you figure it out.
You let the theory people have a field day with it.
But it's all in the same venues. Like it's all up in Europe. So that's really different.
Yeah. So it's like RL track will have these two totally different camps.
I see. Yeah. In like databases and like distributed systems, it's super split. Like there's like an all theory conference for databases and then like a not theory conference and like all theory distributed systems. Yeah. It's different because like if you want to read papers of a certain type, like where to look. You don't get like random papers full of proofs if you don't want that. It makes it really hard, I think, to work on problems that are like a mix of the two sometimes, or like to figure out how to package those. But in general, it's nice.
That's nice because they know what to ignore.
Yeah. This is a problem in ML conferences, I feel. Maybe it's because it's like the field has grown so much. I don't know if in time we'll just start seeing more and more conferences. But I feel like, especially like NeurIPS, which I think was the first ML conference that was made. But like there are conferences that are like, there are a lot of just general ML conferences, and some of them are slightly more associated with like maybe theory, and some that are maybe more associated with experimental results. But I wouldn't say that like if you write a theory paper, if you write an experimental paper, like I feel like you can submit to like all of these types of conferences, and they accept like thousands of papers or something.
Oh yeah.
And so that's an issue of like, I don't know if you had this at NeurIPS. You like walk into the poster session and it's like hundreds of posters and they're like, oh, this is RL. And you look at like I was looking at the explainability section, and I don't know, explainability is big. It's not like that. It's not like as big as RL. And I would go from poster to poster and I'm like, these are in like different universes.
Yeah.
Like,
NeurIPS is insane this year.
Yeah.
Just everything blended into each other and nothing made sense.
So much,
It's like a fever dream.
Yeah.
I really want to see this like massive scale crazy conferences.
You should come.
Where is it this year?
I don't know, actually.
Seattle?
Maybe Seattle.
Might be
Maybe
Seattle.
Vancouver.
Definitely the US.
Yeah.
I don't know, maybe you'll see me there.
Yeah. Cool.
Take the podcast on the road.
Yeah.
Dude, road podcast.
I saw NeurIPS is cool this year. I saw like Max Tegmark explaining his PhD student's paper. I saw like a bunch of cool people just like, it was cool seeing like
great,
tenured, like big name professors
Yeah.
at the posters with their students. It's pretty cool.
Yeah. I guess Peter doesn't really go out to, or does he go to conferences? He's like busy as hell.
Yeah, he's not at conferences these days, I think. I don't know.
Yeah. I wonder what the differences between like I feel like there are some professors that just really value going to conferences. Like I feel like a lot of the vision professors really value it, but like I don't know, like Joey doesn't go to conferences. Like I know some of the NLP people don't go to conferences.
A lot of the Scala professors don't go to conferences.
Yeah.
I don't know.
Conferences are fun, but like I don't know how it is in databases, but for ML, like, we're kidding ourselves if we think there's any signal in like the papers that get accepted. Maybe there's some signal. Like just enough to prove that like maybe it wasn't like copyrighted or anything. But
even
then, yeah, there's like some famous instances where that's not true. But if you really care about like just results and about showcasing strong work, then I think archive is mostly what matters. Archive and like good open source implementations that people can reproduce.
Yeah.
But I don't know. Honestly, I don't think going to a conference like has much added value these days. Maybe some small conferences you can actually like connect with people more. There's one I really like called Coral, Conference on Reinforcement Learning, or on Robot Learning. Sorry, that conference is great because it's like 300 people. It's always in some cool place.
Yeah.
Like last year was New Zealand. So I saw you there, and you just connect with these people, hang out, grab drinks, maybe talk about their work. Maybe not.
Yeah.
I think that's like the larger function of conferences for the most part. It's like you're meeting, you're hanging out with people in other areas of the field and seeing what, like hearing what's going on in that context, not like through talks and posters as much.
Right.
But
yeah.
I mean, if you're a professor and you've been in the field for 30 years, maybe you're tired of seeing those people. I don't know.
I know enough people.
Yeah.
And Nerves this year was especially hard to connect with people. I don't know about you, but it just felt like there were so many people.
Yeah.
You just kind of ended up hanging out with your own cliques most of the time because it just felt like, I don't know, it just became, like the mass of people was too great. It felt like I was in a little city.
Yeah, it really depends. Like, I think this is a situation in which I understand why professors are not super excited to go to these conferences because they are so big and it is so like much. But, you know, like I think incoming students, it's really overwhelming to go. And I've had sort of like in the ML conferences I've been to, like it either goes one of two ways. Either I'm so overwhelmed, I just hang out with the same people all the time, or I like, you know, only hang out with new people. But the scale makes it pretty hard.
Yeah.
And especially because I feel like, you know, a lot of times the professors that you want to talk to, it turns out they're not there. They're like meeting with 45 other people.
Yeah.
Like, I don't know, it's definitely not as easy.
Yeah.
Or you have to be quite like courageous to go up and talk to people.
Yeah. I find that can be tough. Very tough. And databases, the conference is around 1,000 people.
It's still pretty large.
So like, yeah, it's like, yeah, you can meet new people every time. But yeah, you can also end up in like your cliques. I mean, we usually have like 10 plus students just from Berkeley. It's like easy to just end up only hanging out with them or like only hanging out with like the other grad students you know from other schools.
Yeah.
Which is also fun.
Yeah. It's a good time anyways.
Yeah.
I'm not really at the conference for work most of the time.
Yeah.
I'm there for leisure and exploring the city.
What's the most fun conference you've ever been to?
Honestly, it's London, like right after the pandemic.
Really?
Yeah. It was this conference on reinforcement learning. It was like 200 people. It was like maybe their third or fourth year doing the conference. It was still pretty small. 250 people. We had this cool venue in like downtown London next to St. Pancras Station. It was such a great time, and like we rented a 4-story Airbnb next to Regent's Park.
Wow.
Yeah, this was with Ken Goldberg students, and we just threw this like big party, and like it was such a small conference, like half the conference was there. And this is like right after Squid Games, so like maybe this won't age too well, but like we printed out the Squid Games business cards, and handed them out at the conference.
I'm so sad we didn't do that for Nerves.
Oh, I know. We
should have done business cards.
Oh, that's awesome.
Yeah, we still had a little something there, but that conference was so great. And honestly, like every conference has been a lot of fun. The smaller, the better, though.
Yeah.
Always.
A lot of the small conferences in my field are held in Santa Cruz, California, which
like a spider retreat?
Well, like that, but like the like Symposium on Cloud Computing is often there. The database like kind of vision conference is often there, which is like, it's a very nice setting because it's small, but then I've been there like a million times and it's like in my backyard. It's like not an exciting location at all.
Well, is it because the companies are there, or I guess South Bay?
Yeah, like the Bay Area, it's easy to attract a lot of companies and stuff, I guess.
Makes sense.
Yeah.
Mm.
I had the like opposite experience for my first conference right after the pandemic, like late 2021. I went to my first conference in a long time, and it was in Copenhagen. It should be really exciting,
That's
like
amazing.
people getting back together. But I knew 0 people going to it, and there were like almost 0 Americans there. So I show up, and it's like, the like tables of people like talking to each other, and you like walk up, and you're like, "Hey, I'm Connor. Like, what's up?" But it's already hard to just walk up to a bunch of strangers and like, "Hey, what's up?"
Yeah.
All of them are not speaking English.
Oh.
So I'm like walking up to a table, and I'm like, "Hi, I'm Connor. How would you like to switch languages and like get to know me?" And I felt like super, super awkward.
Interesting. A non-English speaking CS conference.
Yeah. I mean, there's like a lot of people who are from different European countries, like hanging out with their cliques of
their
folks who spoke
Italian,
German or Italian or whatever.
Yeah, I see.
So it's like, extra hard to break in.
That's tough. Did you end up breaking in with some people, or?
Yeah, I found people to hang with, but
So explore Copenhagen. Maybe you can slack.
We rented some bicycles and did the whole Copenhagen thing.
That's amazing.
But
I want to see it again.
Yeah. So, do you think in research or machine learning in particular that you need a social media presence to be successful in academia?
No. I know, because I just know a bunch of people that don't have a social media presence and are very successful. Now that so it's not now. Some of them do, but I know when they were like doing their good stuff and getting lots of citations for their work, they did not have a social media presence.
Do you feel any pressure to like market your research in a like really palatable like way for social media?
So like, yes, I do feel the need to market my research, but I don't feel the need to do it over social media. Actually, the opposite in a way. I like deleted my Twitter recently because I just felt like there was no signal anymore. Again, like Twitter, because everybody feels the need to do this, I guess.
Yeah.
There's just so much like noise.
Yeah.
Even in like the robotics RL community, it's like every week there's a new paper that came out, and it's like, even though it might have gotten like 10,000 likes, I read through it and I'm like, there's nothing new in here.
Right.
So no, but I feel like giving talks and talking to other researchers in the field, promoting it to them, talking about it with them, that probably goes a long way. Doing invited talks, like promoting in the usual circuit, I guess. But yeah, so social media, I feel like, the signal's all gone, for me at least. To the point where it's just like an ego fest. It's just like, look at the cool stuff I did. It's not peer reviewed yet, and like the results are okay, but let me know what you think.
Right. Yeah.
But some people have benefited from it, for sure. I just wish it was more like, when I think about like science communication, I think about social media, and I don't know. I think about the good science communicators, like Carl Sagan or Richard Feynman, and like, would they have been on Twitter this today? Like, hey, check out the new work my lab did. We just discovered this new particle.
Yeah.
Let me know what you think.
Maybe they'd be shitposting on Twitter though.
Maybe. I want to see Richard Feynman memes. Yeah, like the good stuff. Yeah. I don't know. I feel like, and everybody can do what they think is best. I just feel like, for me, it also kind of melts my brain after a while to be on Twitter. So maybe not for me. I will still tweet my papers though.
Yeah.
Sure. You gotta.
You gotta.
And once that advisor retweets, I will wait like an hour before I ask Peter
Yeah.
to retweet a paper,
Yeah.
and it's like sad. That first hour is
Yeah.
like digital tumbleweed rolling through.
Right.
Like it's a desert. And then as soon as Peter hits a retweet, it's like a horde of AI followers just start clicking. It's insane. Peter has for sure like benefited from it quite a bit.
Yeah.
Usability.
No.
What do you
Well,
guys
he
think?
also has a podcast. Maybe that's what.
Oh, competition.
No.
Oh no.
Competition.
I've actually never listened to his podcast, but
He gets good names.
Yeah.
I think he has pretty good questions too.
have you ever been on it?
Not yet. I think you need
So we got you first.
Yeah, you got us first. Ooh.
Fuck yeah.
Yeah. I think maybe you can get Peter on this one.
Yeah. Well, I don't know. I can't even get him for Bear Salon.
Yeah.
Tragic.
Sounds about right.
That's alright. I'm not salty or anything.
Yeah, it's weird. I feel like it's something you can only see in this. I mean, it's like a luxury that you can only afford as a professor in CS to just be able to like take a long leave.
Yeah. What are your thoughts on the CS company, like academia to startup pipeline crossover?
I think some professors do it well and others do it extremely poorly.
Mhm.
I won't name names, but even in Berkeley, there are some pipelines that are like sketchy.
Mm-hmm.
Like, I think we all know who we're
Sure.
talking about, but it's
Uh-huh.
like 2-year PhDs, and then you go work at a company like right after.
Mm-hmm.
It's so sketchy. Like,
Yeah.
it devalues everything. I mean, other labs, like, I mean, I will say, I think Peter does it very well. Like,
Yeah.
he has covariant,
Mhm.
but, you know, I haven't heard of any instance where it's like your PhD is explicitly tied to like working with covariants or,
Mhm.
you know, you have to go work at covariant afterwards. Totally separate.
Yeah.
Never hear about covariant. I think that's a good way to do it. Like, otherwise it's like not very academic, right? To let corporate influences,
Mhm.
you know, into your research or have your research steered by a company.
Yeah.
Yeah, it's probably just bad for everybody involved. If I were to do it, I would probably do the way Peter does, just totally separate and like, you know, if you want to talk about it, we can chat about stuff there, but it's like there's no strings attached. Yeah, but it's interesting. I mean, Berkeley for sure has benefited as far as patents go.
Yeah, it brings in a lot of money.
Tons of money.
So, would you consider academia?
Maybe. I don't know. I feel like it's too early for me to say.
No.
I definitely need to go out into the real world for a little bit.
Mhm.
But already with that mindset, it probably tells me, I feel like if people want to do academia, they know by this point, or the real diehard academics know
Sure.
by this point. So, yeah, no strong feelings.
Mhm.
But I think I'd rather go into the real world and like
Mhm.
try to get compute.
Yeah.
Try to simulate those dogs in the
Yeah,
real world.
Yeah.
Exactly. So, I don't know. I feel like academia is fun, but it also just seems like a ton of work to like
Yeah.
write grants all the time to get students funded. I feel like if you can go and start a venture that like brings in tons of money and then have a research division to your venture, it's probably more effective.
Yeah.
I mean, obviously that's way harder or way more luck involved maybe, but yeah, I feel like especially for CS, like putting it under like a capitalist enterprise, it's probably more effective and you can get more compute.
It also seems more time efficient, like the amount of money you get from a like investor per time spent like pitching is a lot more than per grant that you write. Or
Oh yeah. for like a 10-minute pitch. It's like, all right, here's $50 million. Like, you said you want to like solve pizza delivery. I don't know how you're gonna do it, but here's $50 million. Yeah, there's. I mean, the investing world just seems so crazy. It's just like there's so much money floating around.
Yeah, it's pretty shocking.
It's shocking.
Before moving to the Bay, I feel like I had no concept of the scale of this stuff.
Somebody's telling me like, hey, I know some investors that will give you $10 million just on an idea. No like proof of concept, no MVP, just an idea. It's like, wow. How much money do they have?
Right, exactly. Like, what do you?
It's like jump change.
Yeah.
Yeah, it's insane. Yeah. I mean, we all know people doing startups here. They all seem pretty happy with their lives right now, most of them.
Would you say you're not happy with your life?
No, I mean, I'm happy with my life, but then I look at the academics and I'm like,
yeah, I mean, it's...
What are they doing?
Right.
Are you guys okay?
I feel like there's a bit more existentialism
Yeah.
in academics.
It's like, what are the... it makes sense to be like an academic. I don't know why I think of like academics in like physics.
Mm-hmm.
I'm like, wow, that's cool.
Yeah.
Like, that's pretty cool.
Mm-hmm.
But then I think of academics in CS and I'm like, it's not as like... Because I know in like physics, I can tell for certain they're guided by like the pursuit of knowledge.
Right.
The pursuit of like figuring out how the universe works.
Mm-hmm.
Then in CS, it's like some of these professors, it's like startups.
Yeah.
What are your motives?
Yeah.
It's hard to tell.
Yeah, it's hard for me to tell. Like, I do view CS academia as like, I don't know, less academic or like pure academic than like math or physics. And, well, maybe let's put math in its own category. But something like physics, I'm sure that in physics, there's also a lot of questions of like, is this really purely academic? I'm sure there are like hype trains in physics that some people follow. And I don't know, maybe startups come out of physics. I don't know. Like Jupyter Notebooks came out of physics grad students or something.
Interesting.
But I could have been making that up. I just know the person who one of the people who started Jupyter Notebooks was a physics person.
I feel like I've read this. Yeah, it sounds familiar.
Yeah.
Came out of Berkeley.
Yeah. Nice guy.
Jupyter came out of Berkeley?
I think.
Wow.
I don't know if it. I mean, he's at Berkeley now.
Oh, okay.
I don't know if it came at. I have no idea. Someone fact check that. One of our two viewers.
One of the viewers.
The fans will find it.
Yeah. Pull that up.
But so was a PhD what you expected?
Like when I was a kid?
No, like when you joined. Like what made you go to
school.
PhD? Yeah.
Oh, I see. It felt like a necessity given that I didn't do a CS undergrad to break into AI.
Mm-hmm.
And also, it just feels like you need a PhD in AI now to like get credibility.
I see.
I do know some people that like have gone just like the Google suite route and they've worked up the ladder into like or they switched into the RSci route.
Mm-hmm.
Seems a little hard and not as high likelihood of success.
I think it's definitely the higher effort way. You make more money along the way, but it's definitely higher effort.
Yeah. And you have to like trudge through Google bureaucracy and Google's like ladder systems. So also, yeah, just like it felt like the funner thing to do.
Mm-hmm.
I don't think I was ready to be a grown up yet.
Yeah.
Okay, I'm still a PhD. So
you're so grown up. You're so domestic. You're so waking up at waking up at 7.
Yeah. Getting old.
I know.
Yeah. I'm settling into my Pedro Pascal grizzled.
Yeah, I will say.
Phase. Yeah.
Mm-hmm. No. Well, we just need to throw more ragers, really bring it back, the energy back up.
We do, yes.
But and
first
before
year
8, so it
was like
so
much fun.
Yeah, what happened?
What happened? I feel like
I guess people started working.
working.
It was 2021. I feel like there was a lot of like post-pandemic sort of effect.
True.
Everyone was very excited to be around people and then maybe get sick with people again?
No.
You don't think so?
I mean, I could see that why that's the case, but it's like I didn't want it to end. We should bring it back.
We could just restart it.
I'm down to restart.
Yeah.
I've been considering just hosting more parties for the sake of like
Having people.
it's
over.
a Friday.
Yeah.
Something to
Okay.
celebrate.
Right, yeah. Like someone think of something, we'll celebrate it.
Or even something like low-key, like the European people that I hang out with in Bear, some of them are Europeans, and like they're used to just like grabbing beers after work.
Yeah.
So random Thursday evening rolls around, they're like, "You want to grab some beers?" It's a great time.
Wow, that's amazing.
They're so much cooler than us.
I know, what?
And they have
I've never grabbed
French
beers.
names.
Yeah.
But it's such a cool thing, like to just leave the lab and go grab a beer with like you can talk about work, you can talk about whatever.
Yeah.
But it's amazing. Yeah, let's do that one. Beers now?
Yeah, beers now. All right. Anything else? You feel like have we hit everything we wanted?
You were going to ask about Venmo.
Right. Will you tell us or no?
No.
Fine. All right. We'll leave that as a spoiler for
the next podcast.
the next podcast.
If the people want it.
You're right. Exactly. All
Do you have
right.
any parting advice for listeners out there who might be, I don't know, in an earlier career stage than you, thinking about grad school or interested in the kinds of things you do?
Yeah, I feel like the only advice I would give is I'm trying to settle into this more now, but it's very easy to get caught up in the fame game, the citation game, or like the I want to be a good researcher like them game.
Mm-hmm.
And those objectives are extremely hard to satisfy, and they're moving targets. So recently I've been getting into the flow of just doing things out of curiosity and like satisfying a curiosity itch instead of like caring about anything else. Especially the first couple of years, it's pretty daunting because you're working alongside like senior PhDs or senior postdocs, and it's like, holy shit, I gotta be that good. But in reality, you should just be motivated by like a thirst for knowledge and curiosity.
Nice.
Okay. Beautiful. Eloquent.
Thank you.
Thanks for
Amazing.
coming on.
Yeah.
Thanks for having me.
All right. Beers.
Yeah. Outro music. Is
Yeah.
it the Jeopardy team?
You go.